Let's learn about modular mod development. Hello everyone, this is Ali Raza. Welcome to the Mentor Code Lab. At some point in your mod, you may make a very big decision. You may think that my mod became so big and so complex and I'm covering so many different things that maybe a player will hesitate installing it because the player will not want all of it. For example, in front of the monitor right now, you see a single mod that has different sections. It has cables, a battling armor item system, some effects, some commands, decoration blocks like paintings, like, I don't know, different decorative blocks and special blocks like doors, fences, and etc. Something called goo blocks that we will cover later. Some machines, some ore, some storage system, some tools, and adding their own wood and other different things to the world. Now, on the right-hand side, you see that this guy had sit down and made a possible table of different playing scenarios. This section on the right hand side is someone that wants to play the game. For example, someone may just want to have ore and get done with it. Just because your mod is adding ore to nether, someone may want that and get done with it. Someone may need cables, and of course for cables we need to have some base ingredients, and our sub projects are covering that. But this guy does not need any storage, he doesn't need any armor, anything else. Someone just needs the decoration. Someone wants to play with goose. Someone wants to have the wood and the decorative blocks that come with ore and then craft some tools. He's not interested in anything else. Someone may want the wood and the base decoratives and want to play. However, someone may want to play with machines. Someone wants the armor. Now the armor has effects, and for crafting armors they need items, and some ingredients are some ores that we are generating. Someone may need the cables but at the same time needs the storage. So if you take a look at this diversity, a player that wants to play with cables or maybe storages, he's not interested in goo or tools or machines or armor, none of that. He just needs cables and a storage system. This is why you may want to make the decision to break your big huge mod into different modular sections. However, on the other hand, we have players who prefer to install a single mod and have everything you are providing because they like it. And for example, in my mod will change the whole vanilla recipe, basically making it resource hungry. And someone may like that approach. It's not correct tech, it's not a very tech related mod, but at the same time it's making your early days a little bit more resource hungry. So why not? Someone wants to have the whole thing. If you are going to break your mod into modular sections, this video is for you. So stay tuned to the end of the video because we will cover two different ways of doing it, and we will talk about pros and cons of each approach. The very first thing you need to do is exactly what you are seeing in front of the monitor. You need to sit back and think about different scenarios for the game that can happen as a player. After that, you will make the decision on your structure of sub-modular mod. For example, this planner has planned to have a base sub-project. This base sub-project will produce ingredients as items and few blocks and nothing else. Yes, it will produce tags, for example, and things like that. Then he has cables completely separated. He separated the effects from the armor, and the armor is depending on the effects. He separated the command. Then decorative blocks, goo, machines, and storage blocks, tools, woods, and work. Take note, he did separate the ore generation from the base. Now, as you notice, two of these modules are not depending on the base project. Another one is depending on more than one sub-project. For example, battle sub-project is depending on effect and base. At the end of the line, this guy made this plan, and looking at scenarios, he found something. In most playing scenarios, the player has to install the base and the ore sub-project because he wants to be able to produce the base ore that is provided by the game. For example, in my example, it's citrine, ruby, sapphire, and enderite. So if we have to install ore sub-project in almost every gameplay scenario other than this central one, then why should I keep this separate module from the base? I may want to merge these two together and make it so that they are becoming one single project, like so. And these two will include in one module, and then the others will use this as a base. So when you are doing this sort of planning, you will get a better understanding on what you are doing and what you need to do. After this planning comes the practical phase. Now, on practical phase, you have two different ways of approaching this problem. One is called sub-project parent project system. Now, this is a well-known system. In this system, you produce a hierarchy of subprojects inside a single development environment. It's easier to show you an example. Now, this example is empty, and you can find it on a repository on GitHub as multi-sub-project template, something like that. As you notice, we have these two subprojects, Ultra IO Cable and Ultra IO Base. If I open them, you notice another build.gradle, gradle.properties, everything. And on the top layer, we have again build Gradle, gradle.properties, and everything else. This is one approach, and I will teach you this approach today. The other approach is something that I called it a standalone multi-project system. Now, what do I mean by that? If we compare these two approaches together, both of them have different projects sitting in the hierarchy. However, on the top layer, the sub-project parent project system has another build.gradle task. And here on the right side one, we don't have that. Also, take note that the Gradle hierarchy has a top level, and inside that top level, we have two different sub-projects. On this one, we don't have a top level. Now, each one of these has their own benefits and their own downside. The benefit of structuring your mod like this one, it's easier. Basically, you have more than few mods that are sitting in a folder. If I open it in File Explorer, you notice that it's just a folder with some subfolders, and this .idea was created when I opened it inside IntelliJ IDEA. There is nothing else other than these folders, and each folder is a standalone mod project. So creating this for starters are much easier. You just add some folders, and in each folder you create another separate mod, and then you start with one mod. For example, in this hierarchy that we talked about, you will start with the base. You will finish your base mod. Then you will publish this base mod somewhere like modrinth, and you create the second folder on the parent hierarchy. And again, a new mod, but this time you will add a dependency to the base project like you depend on any other mod out there using modrinth's Maven system. And then you continue on until you finish all of these sub-projects. After that, you have a bunch of mods that are published on modrinth. Finally, you create one last project, and you import and include all of those projects inside this final project. This final project has no code other than an entry main initializer, and its purpose is to gather every sub-module into one jar file. And because of that, we will use include inside our build.gradle when we are depending on these submodules, so that when we build this last project, it will gather and include all of these jar files inside itself. Finally, we have a system that player has the flexibility in using it. He can install each one of the modules as he wants, or install the top level mod that includes everything. The problem with this approach is that you will have to move one project at a time. Basically, you have to create your first project, build it, upload it to modrinth, and then move to the submodule number 2. And you can't have the whole system together and test it until the whole thing is finished. Some people may not like it. However, there are benefits into it. It's easier for maintaining your dependencies. It's easier when you want to handle data gen creation. And trust me when I say it, it's much easier when you are handling data gen this way compared to the other approach. Now, if I take a look at the second approach, and I want to open it on Explorer, let's move the previous approach to the right side to compare. In the previous approach, you don't have anything other than the folders in the top level. However, in this one, on the top level, you see some folders that are related to the mod project itself. Basically, this is the top parent mod. And inside of this top parent mod, you see that we have sub-projects that are children, and each one of them, again, is their own mod. Now, setting up this approach is a little bit harder. Let's cover the first approach, end it, and then come back to the second approach. Basically, in this approach, you have nothing other than your current knowledge. You just create a mod, you add the sections that you think is proper for this mod, you will build it, publish it, then using the Maven from modrinth or Cursed Forge, you just depend these sub-modules to each other, and then the whole thing will be collected into the final approach. However, this approach is a little bit harder, and this is the purpose of this this video. Before I move forward, let's answer one question. Is it worth having a system like this? No, not really. Is there any benefit to use this approach compared to the previous one? The only benefit is that you can work on multiple sub-projects at the same time without the need of progressing forward step by step. Basically, you don't need to finish your base, publish it, then move to the cable. You can just work simultaneously on both of them. Unfortunately, on Modrinth, you can't publish a project without having a version, final version, a built version. And that's a downside of that approach. However, this approach gives you the flexibility of working on multiple subsections at the same time. The downside, oh God, is that this approach is much more complex, especially when it comes on building and running some tasks when you are depending on another project. We don't have any control on the load order of this approach. Basically, for example, when you are running datagen on the cable is depending on the base. So normally you would have run the datagen on the base first, make sure that every JSON file is created so that the base is covering everything, and then you come back and run the cable structure. The problem is that when you run the datagen on cable, it will go back and initialize the base, and sometimes we are initializing in the wrong order. There is no control over the order of initialization. Especially in dev environment, it's totally random, and basically in the runtime, it's arbitrary. So we have a random load order. Sometimes the cable initializes first, and the datagen may give you null reference exception because you are depending to something that is sitting inside base and it's not initialized. This is a very bothersome. Basically, if you noticed, I suggested to initialize your fields inside a method and don't do inline initialization. Some people are against it, but well, it's a practiced code structure that C# developers use all the time, and I had seen that even vanilla is using it, so that's what I'm sticking with. Don't use inline initialization, but if you are using multi-sub project like what we are going to teach you today, you may want to move back to inline initialization of your items, blocks, item groups, everything, because you don't have control over your load order. And if your cables are loading before base and you're calling on, for example, the item group of base, then if you didn't initialize the base first, you will get null point exception. So inline initialization will save you there. Let's learn how to do this complex, troublesome structure. On the top level, you will have a build.gradle that looks like every other project. Basically, you have your plugin, you have your version, you have your base, you have your repositories, you have your Fabric API. By the way, this came from 1.21.4, so it's just Fabric API. Then you have your dependencies, and for example, I have dependencies to my library, and again, some third-party mods. However, here is the critical point. Now, on the top level build.gradle, you want to depend into your sub-project. However, if you go and ask an AI-generated response, for example, the GitHub Copilot or Kodo or Fitten, and say that, hey, I want to include a sub-project, it will suggest that you write implement project and just this part. However, the Loom plugin tells you that if you have a sub-project and you want to implement that sub-project inside your parent project or inside another sub-project, you have to use named elements. Take note that it is having a D after name and S after element, and element is starting with capital E. This typing is critical, and you should assign it like this: path colon, yes, you have to type it, your sub-project, then configuration colon, yes, you have to type it, and then named elements. Now, implementation project, this will make the project depend on this sub-project. However, it will not be included in your jar. For this to happen, we have to use include. Using include on top of this will cause the sub-project jar file being injected into your final build. Now I don't have a build to show you the structure, but basically if you look at the final jar system, open it with something like WinRAR and then move into meta-inf subfolder, you will see that the final jar has many jars sitting inside itself. The build.gradle has something else that I will come back to it in a few minutes, don't worry. Then we have just the task for version 21 and version 21. This is a normal jar and normal publishing. Now publishing, I don't need to have it. I think it's regarding to publishing into Maven, but I keep it there to be safe. As I said, I will come back to this process resources. The main goal right now is to understand the hierarchy first. So this is how you include your sub-projects in the parent build.gradle. Let me moving on to Gradle.properties. You notice that these are standard stuff. I added a Java version because this process resources is reading it. The rest is just Fabric stuff. Then we have our dependencies and their versions all over the place. And finally, I moved my mod version to the bottom line. One of the most things that we normally don't touch is the settings.gradle. Here, in a multi-sub-project parent project structure, we have to open the settings.gradle. We assign a root project.name. Take note, project is capital P. And this is our root project, and you see it on top of the Gradle hierarchy. Then we include every sub-project that we have. Take note, in the whole hierarchy here, this is the only settings.gradle file that you should have, meaning that none of your sub-projects should have this settings.gradle. Now, to make this thing easier for yourself, it's easier to have a template that is generated by Fabric itself, and each time you are making a sub-project, just copy-paste at least this section. You don't need the license, but the other sections, copy-paste. Remember, we are not copy-pasting setting.gradle. Now, this is our first sub-project. This name should be the same with this name, should be the same with this name. Opening it, as you see, I had copy-pasted everything from the template generator, and of course, I ran the game, so the build.gradle and things like that is created. Now you will sit back and, as any other project, add your main data gen and reference. However, take note, I did name it main base, and in other project, I did call it main cable. And if I had 10 different sub-projects, I would call it main with the specified name of that project. This helps me identify what I'm calling from what class at what time. Because in future, I will be depending on the main base, for example, from the cable, because the main base is carrying the reference of itself. And in this reference, I may have some tags that I want to use in other structures and other sub-projects. So I need to have a way to address this reference base, and the reference base is addressed from main base. Now, if I would want to call it from cable, for example, the way that I have is this: main base dot reference, and I would have access to anything that I have on reference. However, if I call every one of these main classes main, then for importing them and using them, I would have a headache. So this is one thing that you need to remember. Make sure that your classes are now dedicated to each project. For example, if you want to call it mod items, stop doing that. Call it base items, cable items, decoration items, whatever you need. Just don't use mod items in every sub-project. It will become confusing. Same thing for blocks, block items, entities, I don't know, block entities, item groups, data gen providers, everything. You need to use a specific name that somehow show you what sub-project they belong to. And don't forget, this uninitialize is not being used anymore inside the mod items, for example. In mod items, your init method is not important anymore. You have to use inline initialization, and the init method is just there to call the class, and cause the initialization to happen. Apart from this naming convention, each one of these sub-projects will have its own Fabric mod JSON. Take note, the top level project has a source, and inside source we have Java that has its own main, and again, Fabric mod JSON. Now, Fabric mod JSON will have two different dependencies as your sub-projects. For example, I had many things. Let me clean it up. And as you see, I have two sub-projects, one for ultra base and one for cable. Or if you want to have it for future, yes, you can have as many things as you want, but these are missing right now because this is just a template. I was playing around to make a template to show you the whole thing. So inside your top level Fabric mod JSON, you will add these dependencies. You can ignore it, but it's better to have it. And the top level main is called main. As you see, it's just logging something. You will never ever do anything related to your mod inside the top level. And of course, I have a hierarchy of folders as template that I can copy paste inside any sub-project that I want. Each sub-project has its own resources, Fabric mod JSON. As you see, the cable one, for example, is now having the dependency for the base. The base one has no dependency because, well, that's the base structure entry point for my mod. Before I move to this section and show you why I did it like this, let's talk about the build.gradle and Gradle.property. The build.gradle in every sub-project is almost the same concept. Basically, as you see, the most sections are the same. We have repositories, we have Fabric API, we have the task, we have the Java, we have the license and publishing. As I said, we will talk about process resources again, but the things that you should keep note is that my Gradle.properties has no other thing other than assigning the memory and just a Maven group and archive-based name. Other than that, I have nothing in that Gradle.setting because I'm reading everything from root project. Now, the root project is the top-level project. It will come and look at this Gradle.properties and read things from here. So whenever I'm using root project, I'm telling the system that, hey, look into the Gradle.properties on the top level. Basically, I'm reading my mod version from here. So I just changed this number and every sub-project will have a new version number. The base, normally you don't see it like this. You just see project.archive base name. I add it here because some people may decide that their project name may want to have spaces, for example. This will fix the problem for that, but it's not related to the multi-project system. Notice that for the group and the archive name, I'm using project because my sub-projects Gradle.property is providing them specifically for the sub-project. Other than that, everywhere that I'm relating to a version, I'm using root project, including whatever I'm writing inside process resources. Every one of them is reading root project. Now, even when you sync your Gradle, you will see some highlighted errors that says no candidate found. Ignore it. It will work. Trust me. Other than this, the only thing that you should keep in mind, if you are depending on something, for example, in base, and then the cable is being dependent on base, build.gradle on cable should have those dependencies, even if it's not using it. For example, in the base, I'm using config because I want to create a config file for myself, okay? Now, cables may not have any configs, but because my base is depending on the config, I have to depend to the configs on cables too. And as you see, I'm depending to the base. So anything that this one has as dependency, the cable should add as dependency. Otherwise, you will see some errors saying that we can't identify this or that because cable will not understand some code that sits inside the base. And that's the only thing that you should take care about. And that's exactly why you have this hierarchy of sub-projects being planned. So for example, you know that anything that sub-project base is depending on, all of these ones need to depend on. However, the effect and command can be different and doesn't need to have those dependencies because they are not depending to the base. And finally, your top level build.gradle, as you see, will depend on everything that every sub-project is depending on. Okay, finally, let's talk about that process resources and what did I show you inside mod.json file. If you ever updated your Minecraft, you will notice that for updating your Minecraft, the process is to come into Gradle.properties, change the version numbers, sync your Gradle, fix the errors, publish the mod. Wait a second, we screwed up. We totally forgot about Fabric mod JSON because it has dependency on the Minecraft and the Fabric loader. If the Minecraft version is changed, if the Fabric loader is changed, you may have some problems here. To fix that, we can utilize the same thing that they are doing by default. By default, your template generator is showing something like this: version colon dollar curly braces version. On the dependencies section, it's using numbers, but in this section, they are showing you something that is usable. And when you come to build.gradle, you will see this: process resources, inputs.properties, version, project.version, and files matching fabric mod JSON, expand version colon project.version. This is how they are looking into fabric.mod.json, looking for the name version like so, and then come back and replace it with whatever number that the project is producing. So we can utilize it. Basically, what did I do is adding the load version, the game version, and the Java version. And inside the top level, if you notice, I mentioned it once, you have this Java version for a reason. Now, inside the post-processing, I just duplicate it and changed it to loader version, project.loader version inside the build.gradle on the root folder, as you see. You don't even need to put this project dot. It is looking into Gradle.properties for loader version, Minecraft version, and Java version. It's here. Now, this is the parent project. By the way, after the first expand, you need to have a comma because it's a list, but on top, you don't need those commas. On the sub-projects, instead of using that project.version and directly reading these values, values, we always use root project dot so that it will refer back to the root project and read these values. Doing it this way lets you to handle the fabric mod JSON automatically at your build time and never be worried about it again. All you have to do is come back into the Gradle.properties, change these numbers, change your mod version, sync the Gradle, start removing the errors, and get ready for a new version publishing, and then just publish it. The process resources will handle this JSON file for you, and that's it. You are done. Now, if you want to have any other special JSON with the same magic happening in it, you will have to have another files matching block and do basically follow these steps. However, I don't think you really need something like that anymore. This is the multi-sub project. Now, you may think that in this approach, we don't need to upload every sub project to Maven or to Modrin. You're wrong. You still need to upload them. The main reason for this approach was that players would be able to handle their game the way they want to. If they want to just have cables, then so be it. So you have to build your sub projects and publish them separately, even in this approach. And that is exactly why I said this approach is not worth it, because in the previous approach, you have control over the flow of data. You just build your first base module, upload it to Modrin, come back, resync the Gradle, and then you work on the second sub project, and then you are running datagen, then you are sure that it will not bother you about the stuff inside the first module. It's already there. However, in this approach, the easiest problem that you will have is that datagen out of order reading things and needing the inline initialization, and even then you may have some problems. For example, you may see that datagen is generating the stuff related to the base inside the Ultra IO cable source main generator. You will see some JSONs there that are duplicated of what you have inside base. And because of that, well, you need to come back and clean them manually each time. That's a headache. Well, you may think that this approach has one single benefit that shines, and that is to have this .gradle file on top level. Normally, you would think that this .gradle on top level will save you some data space on the hard drive because everything will be collected here and your sub projects will not carry their own cache. However, you're wrong. Let's take a look. Ultra IO base has a .gradle, Loom cache, remapped mods, and under a version we have Jiraiya that has 4 subfolders. Each one of them are carrying their own jar. Now, yes, I have this top level, Loom cache, remapped, Jiraiya, and it's still carrying those 4 folders, and each one of them has their own jar. The reason base does not providing anything more is that it's not depending on anything else. If I would add dependency on the base, it will cache the jar files inside itself. So there is really no gain using this approach whatsoever. The only benefit is that if you don't know what you're doing related to the placement of different features inside your submodules. For example, if you are not sure that this feature should sit inside Machina or it should sit inside decorations, for example, then yes, you can have this approach and moving things around are much easier. However, as I said, it has so many problems that I really don't recommend it to anyone. I just produced this video to show you that this is totally possible. It took me so much time because my first problem was that I had these settings.gradle in each subfolder. It was yelling at me. None of the AI generated answers were helping me. And it took me pinging someone inside Discord to identify the problem. And then the second problem was that I had to use this project path and configuration system. And when I had done it, it fixed the other issues. Finally, the only issue that I have right now with this approach is the load order. And for that, unfortunately, I think there is no solution. If I ever find a solution for that, I will make a video about this approach and I will add that solution. Well, at that time, this approach may carry some weight over the other one. But up until then, I would suggest that you avoid this approach and continue with what I provided as this approach. Just some folders, each folder carrying their own project, and each project not depend on the version from hard drive, but on the version that is being published on Maven or on Modrin. When I say Maven, remember Modrin has its own Maven. Finally, last words. how can we make the migration from this approach to any one of the other two? It's tiresome, it's time consuming, because each time you are moving one thing from this hierarchy of classes and everything, you should be sure that you are doing exactly what you need to do, and you should be careful. Of course, this project will have errors, so I will suggest that you make a copy of the folder somewhere else, open it, and then start moving things around from that project, so this one will be untouched.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.